Hi guys, today we are doing vocabulary about Pythagorean theorem. So the Pythagorean theorem is going to be split over 2 days for us so that we can focus on one aspect and then to another. So today we're going to start just by some initial vocabulary about the Pythagorean theorem. So Pythagorean theorem has to do with a right triangle, and a right triangle is any triangle that has a 90-degree angle inside of it. Okay, that makes it a right triangle. The 90-degree angle is shown by the box or the square in the bottom corner of your triangle. So that's this guy right there. That tells me that that angle is 90 degrees. And you've learned this last year in geometry, so that's just a quick review of what it means to be a right triangle. It's a 90-degree angle inside of it. Okay? To continue with the vocabulary, in a right triangle, all of your sides have special names. So we're going to talk about what those names are. The green box points to two of the sides, and these sides are called the legs of my triangle. So these are called your legs, kind of what your triangle is standing on. And your legs are always the shortest sides of your triangle. So those are your short guys. Okay, they're also always going to be on either side of your right box. Okay, so they're always going to be on this side and on this side are your sides, the shorter legs. Then inside of my red box, we have something called, and you may have heard this word in geometry last year, the hypotenuse. Okay, and with the hypotenuse, there's a couple things that are important. Your hypotenuse is always the longest side of your triangle. Oops, get rid of that. The longest side in your triangle. So no matter what, it's going to be the longest in length. And the other thing that's important about it, I can't fit it in the box, so I'm going to put it underneath, is that it's always opposite the 90-degree angle. So what I mean by that is that your 90-degree box is in the corner and your hypotenuse is always across from it. So it's on a diagonal, your hypotenuse, and it's the longest side of your triangle. So when we talk about the Pythagorean theorem, you also may have done this in geometry last year. The Pythagorean theorem is a squared plus b squared equals c squared. And I'm going to write that using the colors shown above. So a squared, notice how it's inside of parentheses, plus b squared, and that equals my c squared. So a and b are your legs, those are the shorter sides, and c is always your longest side, the hypotenuse. So that's what we're going to fill in the blanks below. Where A and B are the legs, always going to be your shorter two sides, and C is going to be your hypotenuse, or the longer two sides, or the longer one side. Okay. And what is the Pythagorean theorem used for? So if we were given two sides of a triangle, the Pythagorean theorem is always just going to help us to find the missing side length of a right triangle. So you'll always be given two sides, and you're going to have to use that Pythagorean theorem to find the third side. So let's try some examples. Example number 1 on your sheet. We have 3 centimeters and 7 centimeters. We're talking about lengths here, guys, so there are always going to be labels for units. First thing that I like to do when I'm asked to do the Pythagorean theorem to solve for a missing side is I like to label my sides A, B, and C. So A is going to be either 3 or 7. It does not matter. I'm going to choose A as the 3 centimeters, and B as the 7 centimeters. It doesn't matter because they're both the legs, so they're going to the same place. The only thing that does matter here is that our C is the hypotenuse, and that's what we're trying to solve for, our longest side. So now let's go back to our Pythagorean theorem formula, which we remember is A squared plus B squared equals C squared. So I'm going to fill these in with what I know. I know that A, and I'm going to bring it down here, that A is the number 3. So I'm going to take 3 and square it. Plus B is the number 7. So I'm going to take the number 7 and square it inside of parentheses, guys. And then equals my C squared, which I don't know at this point in time. So I'm just going to leave it as C squared. Okay, let's start by doing the math that we do know. We know that 3 squared is just 9. And we know that 7 squared is just 49. And all together that equals C squared. And now we can drop the parentheses just like we did for 9 and 49. Now I'm going to add those two together because that's the only math I see feasible here. 9 plus 49 gives me a total of 58. So I have 58 equals C squared. And to get rid of a squared, this is where your square root comes into play. We're going to take the square root of both sides. And what that does is it takes the C and it cancels out the squared and the radical. So now I'm just left with the letter C equals. But that radical 58, this is why we worked on simplifying radicals on day 1 of the unit, because I wanted to make sure we remembered how to simplify radicals. So let's try and simplify radical 58. I know that 58 is even, so 2 goes into it. And 2 times 29 gives me 58. But I can't break down 29 anymore. So my final answer here, guys, is that C equals radical 58. So we tried to break it down. We figured out that we can't break it down anymore. And again, because we're dealing with a side length here, centimeters, centimeters, so you should have radical 58 centimeters in your final answer. Okay, let's try another one. The same steps involved. So example number 2, we have 6, 6, and we're trying to solve for our hypotenuse again. So if you need that little refresh, I'll write the formula up here on the side for you. It's just A squared plus B squared equals C squared, all inside of parentheses. So I like to start by labeling my sides. It doesn't matter which one is A or which one is B, so just label them accordingly. In this case, they're both the same number anyway. But C is always the side across from your square or your 90-degree angle. So we have A, B, and C. Now we can start plugging in some numbers. So A squared is 6 squared plus B squared is 6 squared equals C squared, which is just going to stay C squared because we don't know what that is. We're trying to solve it. All right, let's start doing some of the math. So 6 squared is 36 plus 6 squared again is 36, and that equals my C squared. We can drop the parentheses for all of them now. I want to add together my 36 and 36, and that gives me a total of 72 equals C squared. Now to get rid of the squared, remember we need to take the square root of both sides, and that cancels out the squared and the square root, so I'm just left with C equals. But I want to go back to that 72 and try and break it down if I can. So 72 is really 2 times 36. Again, you can break this down however you want to. I just chose to use 2 and 36. 36 can break down into 6 and 6. And then I like to get rid of that 36 as I go. And then 6 we can break down into 2 and 3. get rid of the 6. And same thing over here. We could break down into 2 and 3, get rid of the 6. So I have some pairs here. I have a pair of 2's, and I have a pair of 3's. So remember, pairs go outside of the radical and they get multiplied together. So 2 times 3 gives me 6 on the outside. And then radical, the number that's left over here, that's all alone, is the number 2. So that's my 72 broken down into 6 radical 2. And then don't forget, we need our labels. So because they gave us feet and feet, we need to have feet in our final answer. So my total for side C is 6 radical 2 feet. You always want to break down your answer to as simplified as it can be. Okay, our last example that we're going to do together is example number 3. Example number 3, we have sides 3 meters and 5 meters. So let's start by labeling our sides, our A, B, and C. Again, it doesn't matter which side gets what. I'm going to do A is 3 and B is 5, but you could switch them if you want to. And C is what we're solving for, just like in the last two, because it's across from our 90-degree angle. Okay, our formula, just as a reminder again, is A squared plus B squared equals C squared. So we're just taking everything that we know and plugging it directly into our formula. So let's start with sides A and B. So A is 3 squared plus B is 5 squared, and that equals side C, which we don't know, so we're going to leave it as C squared. Okay, notice same steps, guys, as the last two. 3 squared is really just the number 9, plus 5 squared is the number 25, and that equals my C squared, but I can now drop those parentheses. Next step, I want to add together what I can, so 9 plus 25 gives me a total of 34, and that equals my C squared. And then last step, I want to take the radical of both sides, because what that does is it cancels out my square root and my radical, so I just get C by itself. And then break down 34 if you can. So 34 is even. I know we can divide it by 2. 2 times 17 is 34, but I can't break down 2 anymore, and I can't break down 17 anymore. So this example, again, it looks kind of weird because it's just the exact same number, radical 34. It's the same as example number 1. We can't break it down anymore, so that's your final answer. But they gave us meters and meters, so in my final answer, radical 34 meters. Okay, each one of the examples that we've done has quite a bit of work shown, so I do need to see that work shown for numbers 4 through 10, okay? So please do 1 through 3 with the video, and then 4 through 10 on your own. If you have any questions, like always, guys, I'm available on office hours. All right, have a good day.